Use the principle of mathematical induction to prove that 5 plus 8 plus 11 plus plus 3n plus 2 equals n times 3n plus 7 over 2. Observe that the terms increase by 3 each time. The common difference is 3. 5 plus 3 is 8. 8 plus 3 is 11, and so on. To use the principle of mathematical induction to show that this is true, we need to come up with the statement for the integer n. The statement is that the sum will be n times 3n plus 7 over 2. We will show that this is true for all n using the mathematical induction proof. First, the base case. The base case is when k equals 1 or when n equals 1. P sub 1 is 1 times 3 times 1 plus 7 over 2, which is 10 over 2, or 5, which is true, because the sum of only the first term 5 is 5, and it follows this formula. For the induction case, we assume that it is true for n equals k. We assume that the statement holds for n equals k, which is k times 3k plus 7 over 2. And we will need to show, this is not true yet, we still need to show this. It is true for p of k plus 1, where we replace k with k plus 1. K plus 1 times 3 times k plus 1, don't forget the parentheses around k plus 1, plus 7 over 2. We will need to show that the sum of the k plus 1 terms is k plus 1 times 3 times k plus 1 plus 7 over 2. Again, this is not true yet. We still need to show this. What this induction step is saying that assume that the statement is true for any k, show that it is true for the next k plus 1 term. To do this, we consider the sum with k plus 1 terms. This is the sum of 5 plus 8 plus 11 plus plus 3k plus 2. There are k terms already, plus 3k plus 1 plus 2. This will give us k plus 1 terms. Since we assume that the statement is true for k terms, the sum of the first k terms is therefore k times 3k plus 7 over 2. And what left is 3k plus 1 inside the parentheses plus 2. And this will be the sum of the first k plus 1 terms. Simplifying this, we have the sum equals k times 3k plus 7 over 2 plus 3k plus 3 plus 2, which is 3k plus 5. We then combine the two terms, the first term and the second term, by multiplying 2 over 2 to the second term so that we have the common denominator of 2. This is now 3k squared plus 7k plus 6k plus 10. Combined like terms, we have 3k squared plus 13k plus 10 over 2. And this can be factored to k plus 1 times 3k plus 10. To show that this statement is true for the k plus 1 terms, we need to have k plus 1. Again, this is what we need to show. We need to have k plus 1 times 3 times the quantity k plus 1 plus 7, We then manipulate it to make it look like the case k plus 1. We keep k plus 1 and then 3 times k plus 1 plus 7 because we split 10 to 3 plus 7 and we factor out the 3. Notice that if we multiply this out, we end up with 3k plus 3 plus 7, which will give us 3k plus 10 back. But this is the form that we need to show. Since the statement is true for both the base case and the induction case, we conclude that by the principle of mathematical induction, the statement P of n equals n times 3n plus 7 over 2 is true for all n. The way that works is that we only assume that it is true for one particular k, and we show that it is true for the case plus 1. But if both of these cases are true, then we can assume that it is true for all n. And this is the sum of 5 plus 8 plus 11 all the way to 3n plus 2.